Welcome. Today we're going to discuss the Java language for just a few minutes, and we're going to look at some basic syntax in Java that you can use to build a simple program. I'm going to run through some slides pretty quickly, hit some high points, some basic concepts, spend the majority of the time working with code, changing code so you can actually see the concepts in action. As far as learning a language like Java, it's going to be more beneficial for you to work with actual code than it will be for you to read about it or hear about it. You get your hands dirty and actually make some changes and some adjustments and see what the effects are, what the outcomes are, so that you'll be able to get a better idea how things work. Java is a very important language. It's used everywhere. It runs on lots of different platforms and devices. Its flexibility makes it so popular. Why do you want to program? There's tons of jobs available for those people that can write code and build programs. So that's an important thing for you to understand, because that'll give you some idea whether you want to do this or not. And Java is a language that's very popular, so knowing how to program in Java will help as well. Every device that you encounter these days has some kind of code running on it. So the more that you know about how to write code, interact with code, work with code, it's just going to make you more marketable as you go out and try to get a job. Why program? Programming is one of the coolest things you'll ever get to do. You can take ideas floating around in your head. You can sit down at a computer, write some code, build some things, breathe life into some ideas, and the next thing you know, you got a tangible product that you can manipulate, you can work with, whether it's an app, a game, or some kind of instructions that you give into a robot, or whatever it may be. You can take ideas in your head and actually make those become a reality. In Java, a simple class has a name, class A plus comp sci, open brace, close brace. That's the simple starting point that you're going to see on most of your Java programs. Here we've taken that simple class and ramped it up a little bit, added some spice to it. We have a method inside now, the main method, with a program statement that is a print line to print out a string literal. Java syntax rules, we're going to get into this in just a second with the actual live program. If you got an open brace, you have to have a corresponding close brace. If you have a programming statement in here, a program statement like system out print line, you must have a semicolon at the end. We'll look at that in a few minutes too. Indentation is optional, but it makes your code easier to read, makes it easier for you to read it, and it makes it easier for someone else working with your program to read it. Now let's go take a program, an actual Java program, and apply these concepts so you can actually see it in action. Okay, now that we had a chance to look at some concepts and discuss some examples, let's go into an actual working program and make some changes and see what happens whenever we do those things. The program that you got on the screen right now has a class called A plus comp sci, has a main method inside, has one program statement that just prints out A plus comp sci with an exclamation point. So if I go up here, I'm using Eclipse, doesn't matter what you're using. If I go up here and run my program, it prints out in the console window A plus comp sci. We talked about earlier, if you have an open brace, you have to have a corresponding close brace. So if I go down to line 7 and I get rid of that close brace that matched up with the one on line 2, I hit run again, now I've got an issue. Right? The braces come in pairs. I no longer have my braces paired up. So if I go back and put that brace back in, now they're all paired up, everything's good. I can come in here on the method on line 6. I can remove that brace, run it again. You see I end up with the same issue that I had just a second ago. So now let's run it one more time. We're back in action. I go into where my print line is. That's a program statement. I take the semicolon off. I run my code again. Now I've got an issue because the semicolon's missing. If I go up to say where I've declared the method, I put a semicolon there. That's not a program statement. That's not allowable. I run it again. Now I've got an issue there. So what we're doing is we're taking a working chunk of code and we're removing things and adding things and making sure that we understand how it works. This is going to get you the most value. If you go in and look at a few examples and then go to a working piece of code and actually manipulate it and change it and edit it, that's where you're going to learn the most and learn it the quickest, because you're going to actually see results as you make those changes. Now that we've looked at some basic structure stuff, some basic syntax, now we need to look at how to get more values, more stuff printed on the screen. So we're going to use print and print line to get values on the screen, the console window. We'll use printf later, but we're not going to start with that yet. So print is a command where you can tell Java you want to print out a value, a number, a string literal like we have here. It will print that and stay on the line where you print it. So in this example, we have two print statements. A plus comp size printed on a line, and then A plus comp size again printed on that same line, and Java would remain on the same line to print a third value if you had one. Here, instead of using print, we're using print line. So it prints A plus comp sci, moves to the next line, prints A plus comp sci again. And if you were to do another print line, it would print a third line, and so forth and so on. So let's go take a look at this in action. Now that we have a general idea how print and print line work, let's take a look at some code and see what's actually going on, make some changes to it, and see what happens and see what output we get based on those changes. So on the screen, I've got 4 print statements, and each one of those print statements prints out A plus. You'll notice when I run it, all 4 of the words A plus, those string literals, are all on the same line. Print will print a value and stay on the same line. If I change all these to print line statements, then it will print each one on its own line. So let's run this again. Now you'll see you got A plus on one on each line. I could go in here and I could make some changes. I could change some of these to prints, leave some of them as print lines, run it again, and then it's going to change based on each one of those adjustments that I make. So print will stay on the line. If you print more values, they'll all stay on the same line. If you put print lines, then it'll move down a line and print individual pieces on its own line. The other thing that you can do when you're working with this code is come in here. You're probably going to make a mistake or two. You'll delete a semicolon somewhere. It's going to yell at you. That's okay. The best way to learn is to go in and make changes to this code and rerun it and adjust it and see what the output is. That is, you're going to get the most value from actually editing live code when you're trying to learn how all this works. Now that we have print and print line down, we can look at using some escape sequences, which are basically tools that you can put inside of string literals as part of print and print lines to make different things happen. The one you're going to use the most is /n, the new line. Basically, if you place it inside of a string literal in between characters, it basically creates print lines. And so it basically splits up that string literal for you and puts items on different lines. This is one of those ones you just go around and mess with it, and it makes perfect sense. We're going to look at it in code form here in just a second. If you want to print a quote as part of a string literal, you have to preface that with a \. That's another escape sequence. And the one that I like the most, and the one that's, I think, the one you get the most bang for your buck on in the way that you really impress people, is with the \. If you put 2 backslashes in there, you get a \. On the screen. So think about this for a minute. You put 10 backslashes in there, you get 5 on the screen. I guarantee you that will impress people if you show off those skills right there. Here are some advanced escape sequences, /t/b/r/ single quote. I have some examples in here for you. We're not going to spend much time on those. Those are things you can just go mess with on your own. Let's go take a look at these escape sequences and code examples. Okay, let's see how these escape sequences work in action. And as I said previously, this is how you really impress people. If you want to really show off your skills, these escape sequences, it's the way to go. It's the way to make it happen. So let's run this just to make sure everything's good. When we run it, we get A on the line by itself, P on a line by itself, L, U, and S. So let's start with that string literal first. In the string literal, I have a /n between the A and the P, a /n between the P and the L, and then the L and U, and then a /n between the L, U, and S, which means it's basically going to create print lines for each of those chunks and put them on a line by themselves. On the next full line in that string literal, I have /:/:/, which means it puts double quotes in between each of those chunks where I had the /n on the first line. And the one that I really like that's really closest to my heart is the /. And as you can see in here, we get 3 // because we have 6. I'm going to go in here and I'm going to put 1, 2, 3, 4 more. And I'm going to run it again. And look at all those slashes. So if I really want to have some fun, I can just come in here and I can really mess with it. Now let's hope I have an even number. If I don't have an even number, it's going to yell at me. So let me put another one in there. We'll run it again. And now look at all those slashes. So if you want to mess around with some of this stuff, go in there and tinker with it, and you'll see real quick, what's going on and where things can go wrong. So if you thought escape sequences were fun, well, you're in for a treat here, because we're fixing to ramp it way up. So if you didn't know, Java can actually do math. It can add things together. It can multiply. It can divide. The language has a lot of features that you may not have even known existed. So here we have 7 + 8 + 9. So it actually adds those 3 digits up and you get 24. That's amazing. And so if you need to add up some numbers, you can go into a print or a print line and you can have some serious fun. That's another way to impress people. One of the things that's a little odd is if you put a string literal inside of the print line with some kind of mathematical operation like what we have here with addition, it's going to treat everything after the string literal like strings. So in this case, it's going to print out 7 plus space plus 8 plus 9 because it's just going to take the two strings 8 and 9 and add them together. It's called concatenation. Here we have a little bit of a different example. The 7 plus 8 happens before the string literal, so it actually does the math with the 7 and the 8 and gets 15, and then it tacks on the space and then it tacks on the 9. So not really something that's extremely useful, but something that you may encounter that you just need to be aware of in terms of how that works. So let's go mess around with this a little bit in code form so you can get a better idea how this actually works. Okay, let's take a look at these little chunks of code that we just had in the slides in an actual code form. You'll see we have 7 plus 8 plus 9, which is 24, 7, space 8 plus 9, and then 15 and 9. So let's run this and make sure that we are good on what it's doing. Okay, so this looks pretty good. So let's go into the third one. And let's change this up a little bit. And let's make sure that we understand that the same thing that we thought would be happening happens. So 7 plus 8 is 15. It hits the string literal, turns 9 and 5 into actual strings, prints out the concatenated values of 9 and 5. I could come in here and I could put in another plus, add another value. Everything's going to be the same. It's still going to function the same way. It's just anything that happens after those quotes with that string literal, that space or whatever it may be, it's just going to treat those as strings. There's a whole lot more you could do with this in the actual provided example. I have a couple more brain teaser lines in there that we're not going to go into here today, but things that you can mess around a little bit when you have time. To comment or not to comment? That is the question. You should comment your code. 2 front slashes is a single line comment. Front slash asterisk front slash, that would be a block comment. So it depends on what you're trying to do. If you need just a real quick descriptor, single line comment would work. If you have a really large amount of information that you need to use to describe some code, obviously the block comment works better. Error messages or errors in general. Syntax errors occur whenever you're typing in your code and you typed it in incorrectly. You left off a semicolon, as we looked at in some of the prior examples. You may have not put enough braces so you don't have pairs. You may have spelled something wrong. A syntax error is something that occurs whenever you've initially typed in your code and you're trying to verify if what you typed in is correct. A runtime error means all your initial syntax was correct, but when your program fired up and was actually running and doing something, it blew up in the course of running. This could be an app on your phone that would hang up. It could be, a program running on your desktop or whatever the case may be, but it is a program that has to be functional syntactically and actually running, and when it blows up, it's running, which would be a runtime error. We're going to skip over these examples. You can go look at these on your own. If you got everything down, now it's time to go build a program and crank some code.